What is going on in school, Chris?
We finished sets on Tuesdays and we started with polynomials. No, not sets. We finished with real numbers on Tuesday and we started with polynomials. And today we are going to have a class, but today was a holiday.
Ah, holiday. Okay. And geometry still triangles only is going on. Okay.
Regular fold.
Okay, so we had started with isosceles triangle theorem. What this says that in an isosceles triangle, opposite in an isosceles triangle, sides which are opposite, angles which are opposite to the congruent sides are congruent to each other. Remember this? In an isosceles triangle, if you see in this, in an isosceles triangle, two sides are equal to each other. You know that. Now the angles which are opposite to these sides, okay, angles which are opposite to these sides are also congruent to each other. Clear? Then the converse, what it says, if two angles in a triangle are congruent to each other, then the sides which are opposite to those angles are also congruent to each other. Converse, you remember the converse?
Yes, sir.
Okay. Now we can do the next property. There are two main properties in this, and that is called as the 30, 60, 90 degree theorem and the 45, 45, 90 degree theorem. So let's do first one. The first property is 30, 60, 90 theorem. Okay, now what this theorem says, in a right angle triangle, if one angle you know is 90 degree, if another other angle is 30 degree and the third angle is 60 degree. Okay, in a right angle triangle, if one is 90, other is 30, and the third one is 60 degree, then side opposite to 30 degree. Okay, side opposite to 30 degree is half of the hypotenuse. Okay, side opposite to 30 degree will be half of the hypotenuse. Okay, now can you tell me which is the side opposite to 30 degree?
BC.
BC. So BC, the length of BC will be half of your hypotenuse, which is AC. So this is the first proof, first property, and side opposite to 60 degree. Okay, side opposite to 60 degree. Side opposite to 60 degree will be root 3 upon 2 times of the hypotenuse. Root 3 upon 2 times the hypotenuse. Can you tell me which side is opposite to 60 degree in this?
AB.
AB. So AB, length of AB will be root 3 upon 2 times your hypotenuse AC. Did you understand this? That means, suppose if your hypotenuse is 6, okay, length of hypotenuse is 6, then side opposite to 30 degree, that is BC, will be side opposite to 30 degrees BC, and BC will be half of your hypotenuse, which is 6. Half of 6 is 3. That means BC is 3. Okay, that means BC is 3. And side opposite to 60 degree, that is AB, side opposite to 60 degree will be root 3 upon 2 times your hypotenuse 6. So 2 3s are 6. This becomes as 3 root 3. Did you understand?
Yes, sure.
Are you sitting with your textbook?
Yes, sir.
So on your textbook in page number 1, write it down. Write it in your notebook. This. Okay. First 30, 60, 90 theorem. Just write this in your notebook. Draw the diagram also.
Hello. I'm Brandon. Busy or what? Sorry, just a quick query there, Brandon. I want to check when your statements are not loaded on Oracle, what you will do?
Done, sir.
The second theorem is 45, 45, 90. Okay, before doing 45, 45, 90, we'll do this activity that's in your text. So,
Okay. And how much time will this take?
um, okay, in 45, 45, 90-degree theorem, one is 90 degree and the other two are 45 degrees.
That is it.
Okay, one is 90 degree, other two are 45 degree. Now what this theorem says, side which is opposite to 45 degree,
Yeah,
side opposite to 45 degree,
that is the truth. Okay, anyways, thank you so much, Brandon.
side opposite to 45 degree will be 1 upon root 2 times the hypotenuse. Okay, 1 upon root 2 times the hypotenuse. Now, can you tell me which is the side opposite to 45 degree here?
BC and AC.
BC. One is AB
BC
and
and
AB.
AC. And AC. And BC.
No, one is BC, other one is AB.
AB.
So both AB and BC will be equal to each other and both their length will be 1 upon root 2 times the hypotenuse, that is AC. So this is the 45, 45, 90 degree theorem, which says side opposite to 45 degree is 1 upon root 2 times the hypotenuse. Understood?
Yes, sir.
Write it down.
Done, sir.
Okay, what is a median? What is a median? Do you remember?
A median. I don't know, sir.
So in a triangle, suppose this is A, B, C. The line which joins from the center, from the vertex of the triangle to the other side of the triangle in such a way that it divides this triangle into two equal parts. That will be called as the median. Understood? Median. Understood?
Yes, sir.
This line drawn from the vertex to the side of the triangle in such a way that it divides this side into two equal parts. That is called as the median. If you turn to page number 36 of your textbook, you see the definition is written. Segment joining a vertex and the midpoint of this opposite side is called as the median. So this D will be called as the midpoint. And you know midpoint, it divides the segment into two equal parts. So this line AD will be called as the median. Is it clear, median?
Yes, sir.
Okay. Now, median and altitude. Do you know what is altitude now? What is altitude? Altitude.
The height.
Yeah, height or the perpendicular distance. Okay. The height or the perpendicular distance is called as the altitude. So if I draw a straight line, a perpendicular line from the vertex to the side, this is called as the altitude or height. And this height, it does not divide this side into two equal parts. Okay, this and this need not be equal. Getting it? But in median, a median divides the other side, the third side, into two equal parts. Okay. So did you get the difference between median and altitude? Median is perpendicular line. And,
yes.
And altitude is perpendicular line, and median is a line that joins the center, joins the vertex of the triangle to the center of the third side. Okay. Now next is the next property, which says in a right-angled triangle. Okay, next property is in a right-angled triangle. So let me see. Suppose this is a right angle triangle ABC and you draw a median from B to the hypotenuse. You draw a median from B to the hypotenuse. Okay, this is a median. Huh? Then what this median will do, it will divide your hypotenuse into two equal parts. So if this is your median, it will divide, and this if I say point D, then it will divide your median hypotenuse into two equal parts. That means AD and DC will be equal to each other. The same property okay, and it will divide into two equal parts, and the length of your median, that is BD, length of median will be half of your hypotenuse. That means length of BD will be half of AC. Is this clear?
Yes, sir.
That means suppose if your hypotenuse is suppose 16, then half of 16 is 4. So BD will be length median. The length of the median will be 4. Getting it?
So half of 15 is 8.
Sorry, 8. So whatever is your hypotenuse, half of that will be the length of the median. Clear? So we did three things. First we did was the Isosceles triangle theorem, which says if two sides of a triangle are equal, then the angles opposite to them are also equal. Then we did the converse of the isosceles triangle theorem, which says if two angles of a triangle are equal, then the sides opposite to them are also equal or congruent. Then we did 30, 60, 90 degree theorem, which says in a right angle, if one angle is 90 and the other two are 30 degree and 60 degree, then side opposite to 30 degrees half of the hypotenuse, and side opposite to 60 degrees √3 upon 2 times the hypotenuse. Then we saw 45, 45, 90 degree theorem, which says in a right angle triangle, if one is 90 degree and the other two are 45 degrees, then side opposite to 45 degrees, 1 upon √2 times the hypotenuse. In this all we can prove, okay? And then we know median, and we did but there's one theorem on median, which says length of the median is half of the hypotenuse. Okay, this now. Now the proof of 30, 60, 90 degree theorem. It's there in your textbook as an activity. So you open your textbook. We'll understand it from the textbook. So it says, if the acute angle of the right angle triangle have measures, one minute, this is all blurred. So the theorem states that in a right angle triangle, if one is 90 degree, one is 60 degree, another is 30 degree, then side opposite to 30 degree is half of the hypotenuse, and side opposite to 60 degrees root 3 upon 2 times the hypotenuse. So let's see the construction. Before starting with the proof, we have to do a construction. Now, what is that construction? It says take point D, extend AB and take point D on it. And you have to extend this in such a way that AB and BD are equal to each other. Okay. Once you extend it in such a way that AB and BD are equal to each other, you join D and C. Okay. You extend BD such that AB is equal to BD, and then you join DC. Clear up to here? What we have to prove? We have to prove side opposite to 30 degrees, half of AC. And also we have to prove side opposite to 60 degrees, root 3 upon 2 times AC. Okay, let's start with the proof. Okay, now two triangles are formed. Triangle ABC, that is the upper one, and triangle DBC, that is the below one. Now, first thing, if you see, segment AB is congruent to segment DB. What will be the reason? What will be the reason?
Because we got halved by.
No. What we did, BD, how did we construct BD? Look at the construction point, construction. Take a point D such that AB is congruent equal to BD. So in these two triangles, the above one and the below one, ABC and DBC. First thing that is written is segment AB is congruent to segment DB. Why? Because we have constructed it only in such a way, no, that both of them are equal.
Oh, yeah.
So here I'll write by construction. Clear? First thing clear?
Yes, sir.
Okay. After that, angle ABC and angle ABC is this one and angle DBC is this one. Both of them are congruent. Why?
Construction.
Yes, by construction. And also, how will we have common you can say. Also, both of them will be 90 degree. Okay, we'll write by construction and both 90 degree. Okay, both 90 degree. And now segment BC is congruent to segment BC. Why? Because it is the BC, this one. In both the triangles, BC is congruent to BC because it is the common
side.
Yes, so you write here common side. Okay, so that's it. Here we have shown a side, here we have shown an angle, and here also we have shown a side. So both these triangles are congruent to each other by which test?
SAS.
So here you write by SAS test. Also, you check in SAS test, the angle has to be between the two congruent sides. So just see, is that angle between the two congruent sides? This is congruent to this, and this is. So you see the angle, it is between the two sides. So confirm, you can say it is by SAS test. Now, since the two triangles are congruent to each other, this angle, or as I said before, when two triangles are congruent to each other, their corresponding angles and sides all are congruent to each other. So, angle BAC, that is this angle here, and angle BDC, that is this angle here, both of them will be congruent to each other. And for that, the reason we can give CACT, corresponding angles of congruent triangles. So if this is 60, this also will be 60. So in triangle ABC, BAC is 60, so BDC, that is, this is also 60 degree. Did you understand up to here?
Yes, sir.
Okay, now let's continue with the proof. Okay. Now, look at this. This is 60, this is 60, and this entire thing will also be 60 because this is 30 and this is 30. 30 plus 30, 60. So this entire thing is 60. Do you understand this?
Yes, sir.
So see angle DAC, that is this one, equal to angle ADC, that is this one here, equal to angle ACD, that is this one here, and all three of them are 60 degree. And if you add all of them, 60 plus 60 plus 60, you will get 180 degree. That means what you can say that this triangle, okay, this bigger triangle ADC, all of the angles are 60 degree. Now, when all of the angles are 60 degree, what type of triangle does it become? Equilateral. In an equilateral triangle, all three angles are 60 degree. Keep this in mind. In an equilateral triangle, all three angles are 60 degree. So in this also, we got all three angles are 60 degree. So we can say this ADC, that is the triangle which I have marked in green, this one, ADC is an equilateral triangle. Now, since it is an equilateral triangle, all three sides should be equal to each other. Yes or no? Since it is an equilateral triangle, all three sides should be equal to each other. That means AC should be equal to AD, should be equal to DC, all these three sides. Got it up to here?
Yes, sir.
Okay. But if you notice one thing, we had constructed AB in such a way that AB and BD are equal to each other. Okay, so AB will be half of AD. Okay, this AB, it will be half of AD. Yes? Did you understand this line? Why AB is half of AD?
So because of construction,
Yeah, because of construction.
we wanted to make it concrete. So
Yeah. So you get A, but see from here, AB is half of AD, but AD is equal to AC. AD is equal to AC. So AD is just replaced with AC, and then therefore we can say that AB is equal to half of AC. And this is what we had to prove. Side opposite to 30 degree, which is AB, is half of the hypotenuse AC. Did you get it?
Yes, sir.
Write it with pencil in your textbook itself.